So for this one, what we talked about was a little bit of a difference for geometric. So arithmetic is when we were adding or subtracting and finding a common difference. But for geometric, we're not looking for that. We're looking for instead something called a common ratio. So that's kind of what we're looking for on this one. I seem to have lost my little arrows. I know we did. So I'm just going to brush through them again because we were missing 8 people yesterday. Okay. There wasn't a podcast. So to get the common ratio, what we're going to do is compare the number and then the number in front of it. So 12 compared to 4, 36 would compare to 12, 108 would compare to 36, and 324 will compare to 108. Okay, every single one of them, if I divide it, what number comes out? 3. So therefore, that's why this is geometric, because it has a common ratio. And then we took a look at number 2, and when we did that particular problem, and so 40 went to 45, and 35 went to 40, and 30 went to 35, and so forth. And then what did we say about this one? Was this one geometric? Yeah. No. Because this one, remember, if we reduce this, I'm going to divide these by 5, so this would become 8/9, and then this is 7/8, and then this was going to be 6/7, and this is 5/6. So this is not, because it has no common ratio. However, remember, if you look at this sequence to begin with, this isn't geometric. What is it? Yeah, it's arithmetic. You're going down by 5. Okay, so again, first being able to spot if it's geometric or arithmetic is beneficial. So this is geometric. Okay, this is the formula that we have for geometric. And so you're going to have a sub n again, and then that's going to equal a to the 1 and then r to the n minus 1. So this one we kind of went through how to do the rule. So we did example 3 and 4 and then we stopped. However, it's kind of good just to brush through this again so we kind of know what we're talking about. So if I did 18 over 6, 54 over 18, 162 over 54, what is my common ratio? So that's the first thing we do. 3. Then I write my rule. A sub n is equal to, do we know the first term in the sequence? Yes, so that's 6. Okay, then do I know my common ratio? Yes, that's 3. And then I'm going to have n minus 1. So there's my formula. Ta-da! Done. But now it says find a of 6. So what am I going to plug in for n? 6. These aren't hard questions, guys. These are actually easy questions. So then I'm going to do 6 minus 1, which is 5. So now I'm going to do 3 to the 5th power and then times 6. And so I can do that because I actually have my calculator up today. Let me clear that out. So notice the happy birthday in there. So there's 3 to the 5th, and then we're going to times that by 6. So that's my answer. So 1458. And so that's the answer to that problem. So that's my a of 6. So again, to kind of repeat the process, first thing again, we divide these to figure out the common ratio. Remember, you're always doing the second number on top of the first number, then the third number over the second number, and so forth. And so when we do this, we did yesterday find the common ratio. So what is the common ratio? Anybody remember from yesterday? 7. So now that I have the common ratio, again, I can write my equation. So a sub n is equal to the number in my first term, and then my common ratio in parentheses, and then n minus 1. And again, we're finding a sub 6 again. So then I just have to plug in 6 here. 6 minus 1 is 5. And so this one, I'm going to just do the same thing, except now I'm doing 7th to the 5th power, and then times that by negative 2.4. So again, I have 7, and it was to the 5th power. And then I want to multiply that by, what was that, negative 2.4? 3.4. So there's my answer. So negative 40,336.8. All right, so that's where, if you were gone yesterday, what you missed. Okay, now, to get on to the next piece, what if I don't know a sub 1? So we're going to talk about that. Then we're going to talk about geometric infinite series, so like how can I do a sum? We'll talk a little briefly. How many people have graphing calculators in here? Anybody? Or no? Okay, just a few people, so it might not be worth necessarily going through if we don't have a graphing calculator. And then we'll jump into a little bit of story problems and so forth. Okay, so for this particular one, what we're going to be doing is this. This one, it's hard to do because I don't have the a sub 1, so it's going to kind of be a little bit tricky. But we can figure it out. So we can figure it out by doing a couple of strategies. So we know that the rule that we have is here. So that's not really going to help me because I don't know a sub 1, but we can kind of tweak it a little bit. So what if I just use these numbers? So let's put in place of a to the n, let's put in a to the 6. So that's 1458. And we don't have an a sub 1, but we have an a sub 3. We can put that in. So that would be 54. And then the common ratio is going to be the common ratio. You just don't know it yet. And then we need to think about, instead of n minus 1, think about what's the difference between our places. Our places here are 6. The places here is 3. So this is really going to be r to the 6 minus 3. So if I think about that, I'm going to have 1458 equals 54 r to what power? 3, because 6 minus 3 is 3. Now, how would we solve this? We want to solve for r. So we have to divide by 54. So I'm going to get 27 equals r cubed. How do I get rid of something cubed?
Squared.
Not square it. No.
Cube root.
Cube root. So we're going to cube root that. Anybody know the cube root of 27? 3. Ooh, we got the common ratio. Woohoo! And so now what I'm going to do, now that I know the common ratio, I can kind of use one of these terms now to help me out and then be able to finish this. So which term would you like to work with? You want to work with the 54 or the 1458? I like 54 because it's smaller, but that's just me. All right, no executive decisions. We'll use the 54. Okay, so let's try this formula again. We'll have a sub n be 54. And I know the common ratio, a of sub 1 I don't know. But the common ratio is going to be 3. And then if this is my third term, now I'm going to plug that in for n. So 3 minus 1 is 2. Let's evaluate that because we can clean that up. What is 3 squared? 9. So I have 9 times a sub 1. So I can solve for a sub 1. What's a sub 1? 6. Because I divide both sides by 9. Now I'm done. Now I just have to write the rule. So my general rule, again, would be a sub n equals 6, because that's my a sub 1. My common ratio was 3, and then n minus 1. And that's my formula.
What is n again?
N is going to be your term number. So the number of your term in the particular sequence. So it just depends. So like here I used a sub 3, and then 3 went in for n. So it just kind of depends on what term you're using for that. Now, if you have a graphing calculator, you can actually type these in. Now, this is where we're getting into sums. But most of you guys don't have a graphing calculator because you need something that has a Riemann sum in it. Okay? And I'll kind of show that on the calculator later on. I'll show you that there's a way to put them in, but you need a graphing calculator to do that. So, how do you do this? How do I find the sum of a finite geometric series? This is the equation we're going to use. And again, this equation is going to be written on your test, so you don't have to memorize it in any way, shape, or form. So we do S of n is equal to, now, to figure out our first number, we have to look at our n. So notice n is 1. So let's plug that in. So in place of n is going to be 1. So anybody know 0.3 to the first power? 0.3. And then what's 0.3 times 4? There you go. So now I just found my first term. That's my a sub 1. Then I'm going to have 1 minus my common ratio. Do I know my common ratio? Sure I do. 0.3. And then for the power, for the n, I got to think about how many numbers do I have. So if I start counting at 1 and I end at 12, how many numbers do I have? So if I count my fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many? 12. It's 12 times. So this is 0.3 to the 12th. And then on the bottom is going to be 1 minus the common ratio, which is 0.3. So we have to put this in the calculator. Okay, so I'm going to show you how to do that. So usually to put it in the calculator, I actually start out with the big number itself. Okay, so we're going to need a calculator to do that. So we're going to need, let me clear this. So we're going to have 0.3 to the 12th power. Okay, bigger number. Okay, now remember there was a 1 minus in front of this. So now I have to do 1 minus, how do I get this again?
Second.
Yep, so second answer. Okay, so there's my numerator, 0.999, Now I got to look at here. Ooh, I got to get my denominator. What would be 1 minus 0.3? 0.7, yeah. So now I'm going to take my calculator, divide my answer by 0.7. Got it? And then, go back to it. I got to multiply it by my first term, which is 1.2. There's my answer, and I'm done. So that's what you would write for your answer for that problem. So 1.7, I just wrote 1.714. Yep. In a couple minutes. So now, for graphing calculators, like Mr. Grumman, if you've got a graphing calculator, you can hit math, and I can't necessarily scroll down on this really well, but if you pick 0, then you'll get this, and that's your Riemann sum. So to put that in, you would just type in x, and then your number, which again, my first number again was 1. And then you go, hopefully above if it lets me. It doesn't always let me. It gets sassy sometimes. See, it's sassy. So anyways, so what you would do then is on the top, you would put in your 24, or whatever number it was. Wasn't it 24? No. What was my first number? It was 12. So I'll type in 12. And then in here, once I arrow again, then I'm going to type in your 4, and then I need parentheses, and then your 0.3, and then your caret, and then your x. And then if you arrow out of it and hit enter, see how these match? So if you have a graphing calculator, you can actually just stick this value in the calculator. Okay, so, but you have to have a graphing calculator to do it. So if you don't have a graphing calculator, then it doesn't do it. Okay, the last one, same idea. So for this one is a little bit different though, because n is 0, so we would put 0 in here. So what's 1.04 to the 0 power? Anything to the 0 power? 1. Okay, what's 1 times 500? 500. So my first term is 500. Then I'm going to have 1 minus my common ratio, top and bottom. But this one gets a power. So I have to think about, if I count from 0 to 6, how many numbers do I have?
6.
0 to 6. 7 numbers, people. 1, 2, 3, 4, 5, 6, and 0. That's 7 numbers. So you got to do it 7 times. You got to count from 0 to the top number. So 0, 1, 2, 3, 4, 5, 6. So you have 7 numbers. So anyway, so then this we're going to plug into the calculator. So to do that, I'm going to need to take 1.04. Let me clear this one out. So we're going to have 1.04 to the 7th power. Subtract 1 from that, so 1 minus that answer. So you're doing 1 minus this answer. Then we have to divide that by whatever 1 minus that common ratio was. So 1 minus 1.04 would be negative 0.04. And then I got to multiply it by the front number, which was 500. That's my answer. So my sum would be 3,949.14. Or I can do it if I have a graphing calculator. I just can go to math, pick option 0, put in your sum again. So you're going to have x. You'll start at 0 this time, so be careful. It always does that. See, it always does that. It wants to not go up to its place. That bothers me. No, it's not a potato, thank you. It just doesn't want to do it. There we go. So anyways, so for this part, then you're going to type in your 6 up there, and then inside your parentheses, we would put in the 500, and then another parenthesis, and then do 1.04, and then your caret key, and then your x, and then arrow out of it. You'll get the same answer. So if you have a graphing calculator, it's very, very handy dandy. Okay, so questions about geometric? No. Story problems? Yeah. So for story problems, let's see, what would be some fun ones to do? Let's do this one. So we're going to do a couple story problems, so you're going to actually have a couple of sheets to do. So for the story problems, what we could do is, for this one, we have a brick staircase that's got 30 steps. The bottom step is 100 bricks. Each successive step, you have 2 less bricks. And then how many bricks is going to be required for the top step? How many bricks do we need total to make this lovely staircase? Okay? So first, decide, is this arithmetic or geometric? So notice it says it's going down 2 every time. Hint, hint, nudge, nudge. It's going down 2. It's arithmetic. Right, that's when you're multiplying or dividing for geometric. This one we're losing 2 every time, so this is arithmetic. So I know my idea is -2 because it's going down 2 each time. Now, do I want to know? I want to know how much is on the top step, and I want to know how many bricks I need. So I'm actually going to need both of those formulas that I have written on the board, that A and and so forth, the formulas that I have here for geometric, which I'll write again on here. So I'm still going to need these lovely formulas. Oh, it's being goofy up there. Oh, geez, the board is goofy today. Okay, so for this one, what we're going to be doing is, first we would probably need to figure out what the general rule is, so then we can figure out how many bricks are on the top step. So we're going to have A sub n equals, do we know how many bricks is in the first, step?
30.
No, I want to know, what the
Oh,
first,
100 bricks.
so there's 100, okay. So that's your A1. Okay, then we have our n minus 1. That's a weird looking n minus 1, but and I've already calibrated the board twice today. It's still kind of goofy. Okay, and then D is -2. So let's distribute that out. So we're going to have A sub n is equal to 100, and then we're going to have -2 times n, which is -2n, and then -2 times 1, -1, which will be 2. So now my general rule is going to be -2n plus 102. All right? So when we think about this, what number am I going to plug in so I can figure out how many bricks I need for the top step? So what do I want? What do I want? A sub what? How many steps are in the staircase? 30. So we're trying to find A sub 30. So we got to put 30 in here. So -2 times 30 plus 102. So -60, yeah, plus 102. So what do we have? So 102 minus 60. 42. So now I know how many bricks I need on my top step. I'm going to need 42 bricks. And then to finish this, now I'm going to figure out how many bricks total I need. So now I'm going to use my sum formula. So how many levels do I have? Because that's what n is going to help me with, which is 30. Then from there, we're going to figure out the first row was 100. Then I need my last row, which was 42. And so I'm going to do 100 plus 42, which is 142. And then times that by 15, because this is really 30 over 2, which is 15. So then we just multiply that. And then that would give me my answer. I think this is the right answer, but some of you guys can double check. So how many bricks would it take to make this particular kind of staircase? It would take 2,130 bricks. And so that's an example of where we would use a happy arithmetic sequence and sum. Okay, one more. Let's take a look at a geometric. That would be fun. Let's do that one. Okay, so bacteria. Remember we did some bacteria back in our lovely chapter with logarithms and exponential, but you can also think about them as dealing with a sequence and series and a sum. So we have a population of bacteria. It triples every 20 minutes. The initial, again, at time being 0, the population is 50. Determine the number of organisms existing after 8 hours. So you could do a Riemann sum with this, but we have to kind of think through this a little bit. So first of all, if we started at t equals 0, we've got that. Okay, do we know what our initial amount of bacteria is? Our A sub 1? Yeah, it's 50. Do I know a common ratio? Think about it. It says it triples every 20 minutes. So what's your common ratio? 3, because it triples. Okay, this is going to be your time. Now the problem is it's this top number. What do I use? Do I use 8? But then if I use 8, I'm not really accounting for the 20 minutes. So we have to figure out how many times is this thing going to triple?
So I can divide 8 hours into minutes.
Okay, so 8 hours into minutes. Okay, so 8 times 60, so that's 480 minutes. And then we're going to divide by 20 because every 20 minutes comes around. So then how many times do I have to go through this? 24. And if you have a graphing calculator, you can actually just plug that in. It's the answer. Okay. If you don't, then this is what we do. So figure out if t is 0. You guys already know that for this one, it's still going to be 50 because this is 0, 3 to the 0 is 1, 1 times 50 is 50. So we should know that. And then we're going to have 1 minus my common ratio. And then how many times do I need that common ratio? Oops. 25 times. Good question. Why? Started at 0. That's why it's 25. If t was 1, then it'd be 24. But it's 25 because of that. And then on the bottom, we're going to have 1 minus 3. And so then this, we're going to put in the calculator. Now, what kind of answer are we going to get?
A big one.
Yeah, big one. So this is going to be quite huge. So first I would probably take 3 to the 25th and find that out. Okay, got that. Do 1 minus this answer. Then I'm going to divide that by, look at this, 1 minus 3. So what am I dividing by?
Negative.
Negative 2. So I'm going to divide by which I did.
Positive.
Yeah, so that will make it become positive again. And then I need to times it by the initial amount,
Oh, yeah, it's 50.
which was 50. That's my answer. Yeah, you're in the trillions. So you could write it as exponential if you wanted to. I mean, you could write, 2.12 times 10 to the 13th if you wanted. So there you go. So there's some examples of some story problems. So for practice, what I want you to do, you're going to get worksheet 12-2, and I want you to try some of the story problems. So that's what you're gonna be doing.